Hello, it's Mrs. Green, and this lesson is going to be on dividing fractions. So we have an example here of the teacher. Hi. And she says, let's try dividing a fraction by another fraction. And sometimes, I'm glad I found this graphic because sometimes it's hard to explain why when you divide a fraction by another fraction, you get a bigger number. And sometimes we can't reconcile that in our mind. It kind of doesn't make sense. It's like, well, you're dividing a fraction by another fraction. Shouldn't it be an even smaller number? And here's a little graphic that shows this box broken up into sixths. So we have 1, 2, 3, 4, 5, 6 parts, equal parts, 1/6 each. And she asked the question, how many 1/6 are there in 1/2? And as you can see from the yellow shaded 1/2, there are 3. If you look at the, first you do the sixths and then you shade 1/2 of the box. There are 3 1/6. 1, 2, 3. 3 of them. So that's why it makes sense that when you divide 1/2 divided by 1/6, or 1/6 divided by 1/2. No, sorry, it has to be this way. 1/2 divided by 1/6, because you had half, and it's divided up into sixths. But it's not sixth of just the half. It's the whole. So when you do that, you're going to flip the 1/6, and we'll cover this in a minute in the lesson, but just to demonstrate. And then I'm going to factor out a 2 from both the top and the bottom. And, oops, this should have been a 1 all along. And now I get 3/1, or 3. So it's a bigger number. It's a whole number. And that seems strange. But this graphic is designed to try to show how that works. It's quite difficult to think of an example in real life where you would divide up. But you do need to be able to do the function. All right, so let's look at the key information. So already in your notes you have prior knowledge. Now we're going to add the key information. And that's going to be the rule for dividing fractions So I've typed it here, the definition. The rule for dividing fractions is to multiply by its reciprocal. So what that looks like there's the words, in numbers. Let's play with some color here to see if we can illustrate this a little better. So we've got, what did I have, 7? And we've got 3/10 divided by a fraction, 4/7. And so we're going, in order to divide by the second fraction, the 4/7, we're going to multiply the 3/10. So we're going to change the operation to multiplication. And we're going to change the second fraction to its reciprocal. And reciprocal is changing the numerator and the denominator, flipping them. The reciprocal of 4/7 would be 7/4. And you can tell because 4/7 and 7/4, if you multiply them together, you get 1. We talked about that in the last lesson. Those are inverses of each other. Reciprocal and inverse are kind of similar words. So now I can solve the problem. The first thing now I have a multiplication problem, and I can go back to my rules from the last lesson, and I want to look for any common factors. There are none between 3 and 4, and 7 and 4, and 7 and 10, and 3 and 10. There's no common factors, so I'm going to multiply my numerators and my denominators, and get 21/40. And because I already checked for common factors, that should be a simplified answer, so I don't have to worry about simplifying my answer as long as I check for those common factors. Some example problems. Example 1 is 5/6 divided by 10/21. I can't divide by a fraction. I have to multiply by its reciprocal. So I'm going to rewrite this. changing this operation of division to multiplication, and then changing the second fraction to its reciprocal of 21/10. Now I have a multiplication problem. I can factor out common factors, and I have a common factor of 5 that I can factor out. 5 out of 5 is 1, 10 divided by 5 is 2, and then I can factor out a 3 from my 6 and my 21. Factoring out a 3 from 6 gives me 2. Factoring out a 3 from 21 gives me 7. So now I have 1 times 7 divided by 2 times 2, which is 7/4. And 7/4 I can also write as a mixed number, which is 1 3/4. So that is a bigger number. That's a whole number, bigger than either one of my original fractions, which we talked about at the beginning. You end up with a bigger number, so I've got to check to see that that's reasonable. My second example problem is 9/14 divided by -2/7. So now we have a negative situation. I'm still going to change my operation, rewrite my first fraction, 9/14, change my operation to multiplication. And when I do that, I can't just change my operation. I'm always changing that number after it. It's like when we're changing subtraction to addition and changing the next number to its opposite. We're using the inverse addition property. Now we're using the multiplication inverse property. So we're changing this second fraction to -7/2. Looking for common factors. 2 and 9, no. 2 and 7, no. 9 and 14, no. 7 and 14, yes. So -7, if I factor out a 7, I get a -1. Factor a 7 out of 14 and I get 2. Multiply 9 times -1, I get -9. 2 times 2 is 4. And then I, again, can write that as a mixed number, which is not -2 and 1/4. Either are fine, either answer. And again, I got a bigger number than either one of my fractions, so that's reasonable. Example 3, I don't know if I'm on 3 or 2A. I'll just call it 3. This is going to be dividing a fraction of 3/5. Dividing a fraction, oh whoops, it's 3/4. I want to match my example. 3/4 divided by a whole number. What would that look like? Okay, so we have to manipulate a little bit. So 3/4, we're rewriting the first fraction, changing division to multiplication. And this, actually, the first thing I should have done was, I need to have that 5 be a fraction. And we can always change a whole number to a fraction by putting a 1 underneath it, because 5 and 5 divided by 1 are equivalent. So now I'm going to flip the 5 and the 1 upside down and write it as 1/5. Looking for common factors, nothing's common, so 3/20. 3/20. Yeah. All right, 4. Now that was a situation where I wasn't dividing by a fraction, I was dividing by a whole number, 5. I changed it to a fraction by putting a 1 after it. So I'm not getting a bigger number here. You might be thinking, well, why didn't we get a bigger number like we have been? It's because this is starting with a division of a whole number, not a fraction. So we have a fraction and we're breaking it up into smaller pieces. All right, last example, mixed numbers. Here we've got 6 1/3 divided by -2 and 5/6. So they're throwing everything at us here. Negative numbers, mixed numbers. So I'm going to rewrite. I'm going to change both of these to improper fractions. So change, and it's the same thing, same first step as we had with multiplication. Division and multiplication, often the rules are very similar. Change to improper, and then we can proceed. So I'm going to change 6 times 3 is 18, so the 19/3. Rewriting this, divided by 17/6, right? 2 times 6 is 12, plus 5 is 17. Oh, -17/3, or sixths. Okay, see how many mistakes I can make when I'm talking here. 19/3, change that to multiplication. Flip the fraction, and check for common factors. So 3 divided out of 3 is a 1. Negative 6 divided by 3 is negative 2. 19 and 17 don't have anything in common. Negative 38, which is 19 times negative 2, divided by 17. Or I can write that as a mixed number. I think that's negative 2, which would be 34. And then that would leave me with 4/17. That's a 4, not a 9. 4/17. So either number is fine. Okay, 3 practice problems. 3/4 divided by 1/8. 5/6 divided by negative 1/3. And negative 5/6 divided by negative 2. So you have a whole number to deal with. And then don't forget to wrap up.